Okay, so picture this. You're at some kind of cosmic racetrack, and you're watching all these moons going around their planets.
Okay.
Most of them following the rules, right?
Yeah,
They're
yeah.
all going in the same direction as their planet spins.
Makes sense.
But then you see Triton,
Oh.
Neptune's largest moon,
Okay.
and it's going in reverse,
Whoa.
like some kind of cosmic rebel.
That's wild, like a car going the wrong way on the track.
Exactly. Welcome to Cosmos in a Pod, the Space and Astronomy series.
It's good to be here.
And Triton's backward orbit is just the tip of the iceberg, I guess you could say.
Love the pun.
This icy world is a total enigma. It's got nitrogen geysers.
Really?
And there are theories about a hidden ocean under all that ice.
That's incredible. So much to uncover.
So in this deep dive, we're going to explore what makes Triton so unique. How did it end up in this crazy orbit? What's happening beneath that icy surface?
Yeah.
And could there be more to this moon than we even realize?
Well, that backward motion, what we call a retrograde orbit, is our first clue.
Oh, how so?
It's super rare for a large moon.
I see.
So scientists think Triton wasn't originally formed around Neptune.
So where did it come from?
We think it was actually captured from the Kuiper Belt.
The Kuiper Belt. That's way out there, right? Beyond Neptune.
Exactly. It's a region full of icy objects like comets and dwarf planets.
So instead of forming with Neptune, Triton was kind of like adopted by it.
That's a great way to put it. Just imagine this massive object, bigger than Pluto, drifting through space, and then bam.
Neptune's gravity snagged it.
Exactly. And that capture would have been chaotic. Probably messed up Neptune's original moons. Maybe even flung some of them right out of the system.
Oh, talk about a dramatic entrance. But besides its crazy backstory, what else makes Triton stand out? What makes it different from other moons?
Well, its surface is truly one of a kind. Incredibly active, but not with the fiery volcanoes we see on Earth.
So what kind of activity are we talking about?
Triton has cryovolcanoes. They erupt with icy materials like water and ammonia.
So instead of molten rock, they're spewing ice. That's wild. How high did those plumes go?
We're talking kilometers high, creating these crazy landscapes unlike anything we see on other moons. And then there are the nitrogen geysers.
Nitrogen geysers, like fountains of gas.
Exactly. They erupt from the surface too, and it shows us that Triton has a lot of internal heat.
Makes sense.
Yeah.
I mean, all that activity has to come from somewhere.
Right. And that heat is likely caused by the gravitational push and pull between Triton and Neptune.
Wow. So we've got ice volcanoes, nitrogen geysers, and what else could this moon possibly have in store for us?
Well, you've heard of craters on the moon, but have you ever heard of cantaloupe terrain?
Cantaloupe terrain. What in the world is that?
I'm serious. Triton's surface has these strange, lumpy features that look like the skin of a cantaloupe.
You're kidding. I've got to see pictures of this.
Oh, they're out there and you won't be disappointed. Scientists are still figuring out exactly how they formed.
What are the leading theories?
Well, it could be connected to the cryovolcanism or maybe even some processes happening beneath the surface.
This is already blowing my mind. Cantaloupe terrain, ice volcanoes, nitrogen geysers. Triton is sounding less like a moon and more like something straight out of science fiction.
Right.
But with all that icy activity, is there any chance for something even more mind-blowing? Like life.
Okay, now that's where it gets really intriguing. While the surface is frigid, there's evidence suggesting Triton might have a hidden ocean under all that ice.
Seriously, an ocean. But how is that possible with temperatures that low?
It's all about tidal heating. The gravitational dance between Neptune and Triton creates friction inside the moon and generates heat.
Ah, so it's like the moon is warming itself up from the inside.
Precisely. And scientists think this heat could melt some of the ice deep down, creating a liquid water ocean.
Okay, so we might have a hidden ocean, but is that enough for life to exist?
It's definitely a promising start. Liquid water is essential for life as we know it. And if Triton's ocean is anything like what we think exists on moons like Europa and Enceladus...
Those are the moons with the confirmed oceans, right?
Yep. And they might contain other key ingredients too, like organic molecules and sources of energy.
So you're saying that under Triton's frozen wasteland, there could be a hidden oasis. That's incredible.
It really is. Of course, life on Triton would face some serious challenges, extreme cold and pressure in a subsurface ocean.
That makes sense.
Yeah.
It would be a very different environment than what we're used to.
For sure. But life is incredibly adaptable. Just look at the extreme environments here on Earth.
True. We've found life in boiling hot springs, freezing cold glaciers, and even miles deep in the ocean.
Exactly. So who knows what might be lurking in the depths of Triton's hidden ocean.
Okay, my mind is officially blown. This is already changing the way I think about moons. But before we get too carried away with all the possibilities, let's compare Triton to some of its more famous lunar cousins. How does it stack up against moons like Europa and Titan?
Okay, that's a great way to understand where Triton fits in. First off, size-wise, it's the seventh largest moon in our solar system.
Yeah.
It's even bigger than Pluto. Europa is a bit smaller, and Titan is significantly larger.
So Triton's definitely in the heavyweight division of moons.
hmm
What about the other features? How do they compare?
Well, we've already established that Triton's retrograde orbit makes it unique. Europa and Titan both orbit in the same direction as their planets.
Right. Right.
When it comes to surface features, Triton's cryovolcanoes and nitrogen geysers are pretty unique.
Okay.
Europa's mostly smooth and icy, with cracks hinting at the ocean below, while Titan has a thick atmosphere with methane lakes and rivers on its surface.
Wow. So each moon really has its own personality. But what about the potential for those subsurface oceans?
That's where it gets really exciting. While Triton's ocean is still hypothetical, scientists are pretty confident that Europa has a vast global ocean beneath its icy shell.
And what about Titan?
Titan's also thought to have a subsurface ocean, but it's probably a mix of water and ammonia.
So a bit different from Earth's oceans.
Definitely.
So it seems like subsurface oceans might be more common in our solar system than we originally thought.
It's starting to look that way.
What does that tell us about the possibility of life beyond Earth?
It suggests that the ingredients for life might be more widespread than we once believed, and that life itself could exist in a much wider range of environments than we ever imagined.
That's an incredible thought.
It really is, and each of these moons is like a unique laboratory for studying the potential for life beyond Earth.
Like we're getting a sneak peek into all these different possibilities for life in the universe.
Exactly. And each one holds the possibility of rewriting our understanding of the cosmos.
This is amazing. We've gone from a rebellious moon with a wild past to the mind-blowing possibility of hidden oceans and alien life. Triton has truly captured our imaginations.
It really has.
And we're just getting started. But before we continue our exploration of this enigmatic moon, we need to take a quick break.
Sounds good.
When we return, we'll delve deeper into the mysteries of Triton's origins, its potential for harboring life, and the future of exploration for this icy world. Stay tuned.
Can't wait. Welcome back to our deep dive into Triton Neptune's mysterious moon.
We've already learned so much about Triton. Like it's a real rule breaker with that backward orbit, the cryovolcanoes, and that possible hidden ocean. But how did it even get there? How did a world like that end up way out there orbiting Neptune in reverse?
That's the million-dollar question, isn't it? Scientists have been puzzled by it for a long time. The most likely theory is that Triton was born in the Kuiper Belt far beyond Neptune.
Ah, so it's not a native of Neptune's system.
Exactly. But the journey from the Kuiper Belt to where it is now, that's still a bit of a mystery.
So we've got this rogue moon, bigger than Pluto, just cruising through the outer solar system, and then somehow Neptune snags it. How does a planet even catch a moon that size?
It's kind of like cosmic billiards, but with way higher stakes. Imagine the gravitational forces needed to capture something as massive as Triton. It's mind-boggling. One theory is that Triton maybe had a companion object.
A companion, like another icy body.
Yeah. Imagine these two objects traveling together through the Kuiper Belt, and then they encounter Neptune.
Oh, so it's like a pair of cosmic dance partners.
Haha, exactly. But as they get closer, Neptune's gravity starts messing with their dance.
Like Neptune cut in and stole a partner.
You got it. So in this gravitational tug-of-war, Triton's companion could have been flung out of the system entirely.
Lost to space forever.
Or even more dramatic, it could have collided with Neptune.
Whoa, a cosmic collision.
Yeah, it would have been a huge event releasing tons of energy.
I'm glad we weren't around for that.
Me too. But anyway, after all that chaos, Triton ended up captured by Neptune's gravity. But its orbit was messed up, leaving it on that backward path we see today.
Wow, so Triton's weird orbit is like a scar for this ancient cosmic event.
That's a great way to put it. It makes you wonder what other secrets it's holding.
Speaking of secrets, we've been talking about that possible subsurface ocean. But could anything really survive down there? It sounds pretty extreme.
That's the big question, right? I mean, yeah, it's cold and there's a lot of pressure, but life finds a way.
Like those extremophiles on Earth?
Exactly. We find life in all sorts of crazy places here, like deep sea vents where it's boiling hot and there's no sunlight.
And super salty lakes and acidic pools.
Right, so it's not impossible that life could exist on Triton even with those harsh conditions.
So there's hope.
Mm-hmm.
And if Triton's ocean is similar to the ones we think are on Europa and Enceladus, it might have what life needs.
Right, like water, organic molecules, and maybe even some energy sources.
But how would there be energy in an ocean buried under miles of ice? Sunlight can't reach that deep.
Nope, definitely not. But there could be other sources, Like, remember the tidal heating that might be melting the ice to create the ocean?
Yeah.
Well, that could also provide energy for life.
So the same forces that create the ocean could also be feeding life within it.
It's possible. And we can't forget about chemical energy sources like we see at those deep-sea events on Earth.
Ah, so even in the pitch black of Triton's ocean, there could be little pockets of life powered by the moon's own heat and chemistry.
That's what we're hoping to find out.
It makes you really appreciate the importance of exploring these icy worlds. It's like opening up a whole new chapter in the search for life beyond Earth. So what are the chances of us going back to Triton? Are there any missions in the works?
There's definitely growing interest in going back to Triton to solve some of its mysteries. One of the most promising proposals is NASA's Trident mission.
Trident, like the three-pronged spear.
You got it. Named after the weapon of Neptune, the Roman god of the sea.
Very fitting. So what's the plan for the Trident mission?
It's being designed as a flyby mission, so it would use a bunch of instruments to study Triton's surface, its atmosphere, and that possible subsurface ocean.
So it's not going to land. It's just going to zoom past and gather data.
Yeah. But even though it's a flyby, it'll be packed with advanced tech.
Like what?
Well, for one, it would have cameras that can take super high-resolution images of the surface.
So we can finally get a good look at those cantaloupe terrains.
Exactly. And the cryovolcanoes and anything else that might be hiding down there.
I'm already excited to see those pictures. What else would Trident be looking for?
It would also have instruments to study Triton's thin atmosphere.
What could we learn from that?
By analyzing the composition of the atmosphere, we can learn more about Triton's history and maybe even find traces of organic molecules.
Which could point to life.
Exactly.
Wow. So Trident could potentially detect hints of life from space? That's amazing.
Yeah.
But what about the ocean? How would it study something that's miles beneath the ice?
Good question. Trident would use a technique called radar sounding to basically see beneath the surface.
So it's like an X-ray for a moon.
Kinda. By bouncing radar signals off the subsurface layers, we can create a map of Triton's insides and see if that liquid water ocean is really down there.
So even without landing, Trident could give us a glimpse into the heart of Triton and tell us if it's hiding a secret ocean. That sounds groundbreaking.
It would be a huge step forward, and it's just one of the many missions being considered. There's also a lot of interest in developing tech that could explore those subsurface oceans directly.
Whoa, like sending a probe through the ice and into the ocean?
Yeah. It would be a massive engineering challenge, but it would be an incredible way to explore those hidden worlds.
Imagine seeing what's down there in an ocean that's never seen sunlight.
Right. It would be like exploring an alien abyss, and it would teach us so much about the potential for life beyond Earth. But even without those super advanced missions, Triton is already teaching us so much.
It's definitely sparked our curiosity today, and we've only just scratched the surface of its story. Welcome back to our deep dive into Triton. It's Neptune's most mysterious moon for sure.
We've definitely covered a lot of ground today. We talked about Triton's strange features, its crazy capture, and even that possibility of a hidden ocean full of life. But what does it all mean? Why should we even care about this icy world so far away?
It's a good question.
Yeah.
Triton seems like a total anomaly, right? This outsider that broke all the rules and ended up in that weird backward orbit around Neptune.
You got it. And that's exactly what makes it so fascinating. Triton's like a window into the early solar system, back when the giant planets were moving around, scattering smaller objects and changing everything.
So you're saying our solar system wasn't always this calm and orderly place. It was more like a cosmic billiards game with planets and moons getting flung around.
Exactly. And by studying objects like Triton, those rule breakers, we can piece together what happened back then, how our solar system formed, and why we see all these different worlds today.
So Triton's like a cosmic time capsule holding secrets from billions of years ago.
That's one way to look at it. And its story also makes you wonder about what else might be out there beyond our solar system.
Like maybe other rogue moons around other stars.
Exactly. If Triton, a moon captured from the Kuiper Belt, could have an ocean and maybe even life, what does that tell us about the possibilities for other worlds out there? Worlds we haven't even discovered yet.
It's mind-blowing. We're talking about rogue planets drifting through space with their own moons. Maybe those moons have oceans too, hidden under ice, and maybe even teeming with life.
It's definitely a possibility. The discovery of exoplanets, planets around other stars, has already changed our understanding of planetary systems. As we keep exploring, we're going to find more and more weird and unexpected worlds, things we never even imagined.
It's so exciting to think about entire worlds out there, totally different from ours, but maybe with life in ways we can't even comprehend.
And that's what makes exploration so amazing. It pushes us beyond what we know, expands our horizons, and reminds us that the universe is way bigger and more mysterious than we can even grasp.
Well, Triton has certainly left its mark on our imaginations today. It's a moon that breaks all the rules, challenges our ideas, and makes us want to keep exploring.
Couldn't have said it better myself. Triton's story from the Kuiper Belt to Neptune shows just how dynamic and ever-changing our cosmic neighborhood is, and that possibility of a hidden ocean, maybe even with life. Well, it reminds us that the search for life beyond Earth could take us to the most unexpected places.
It really has been an incredible journey exploring Triton's mysteries. So as we wrap up our deep dive, what's the one thing you hope our listeners take away from this?
I'd say never underestimate the power of a single moon to change our perspective on the universe. Triton's story shows us the power of scientific curiosity, the thrill of discovery, and the endless wonder of the cosmos.
I think we've all felt that sense of wonder today as we've explored Triton's many mysteries. And if you want to keep exploring the universe with us, be sure to follow and subscribe to Cosmos in a Pod and our YouTube channel. We'll be back soon with another deep dive into the mysteries of the cosmos. Until then, keep looking up and never stop exploring.